Hello class. Well, in this video I'm going to talk about lists, one of the two big data structures in Python. It's kind of hard to do anything without them, so we've been sort of struggling. So let's get a list. Let's make one up. So the first element is 0, that's an integer. The second element is a word, that's a string. And then I can do 4.5, that's a floating point number. 3 plus 2j, that's a complex number. Oops. Have to close it with a bracket. Brackets give you lists. So if you do, if you print that, okay, and then if we want to do it with a program, one way of doing it would be for the index in range, let's see, well, 0 to, we had 1, 2, 3, 4 elements in there, range 4, and then print I A of I. Square brackets. Okay, so that shows that this is an index collection. You describe the positions by indices from 0 to 3, and each entry is in one of those index slots, and the type of data in each slot doesn't have to be the same. In fact, you can make a whole list as one of the entries. For example, here's a list I constructed. Well, let's construct it over here. So here's a list I constructed, and let's make something to put in a sublist. Say S is, I'm going to use my function over there, construct example. I'm not going to try to explain how that works yet. And then the size will be, let's say, 5, and we'll use an S so we can tell which list it came from. And so S is that, and then let's say L of 2 is equal to S. Okay, so let's say print L. Okay, so the second entry, 0, 1, and then this whole thing is the second entry is that sublist. So the way you would reference something in that sublist would be, let's say X equals L, that's the big list, of 2. That's the entry that's the sublist, so L of 2 is the sublist. And then we can reference another bracket to be, let's say, 1. And then X is 1S. So L of 2 was this whole list, and then the second bracket put in position 1, which is there. Okay, so you can have lists in there and lists. I made this one up as an example. You might think of it as a grade book. For each student, you have a grade. I just use first names just to keep things short and simple. So in that list, everything is a sublist. So if you take data 3, you get a sublist, which is the David's information. Okay, so you can nest these things and manipulate them. And the favorite thing to do with these things is index them, and we have slice notation for indexing these things. So, for example, L of, let's say, 3 to 7. Okay, so we get 3, 4, 5, 6. We don't get 7. It's the same deal as we had before with all of these things, namely it's open interval on the right side, so we go up to but not equal to 7. Okay, and then as you know, you can leave off one to get one of the numbers to get a default. So L5 would be everything from 0 to 5, well, 0 to 4, right? And then L3 colon would be 3 to the end. Okay. And then what's L with just a bracket? Well, all the same entries anyway. Whether it's quite the same thing as L, we'll see in a minute or two. Okay, so, and then there's two other nice things you can do with slicing, one of which is you can have a step size, so you can go from 0 to 7 step by 3. Okay, so we went, let's do print L again so we can look at it. Okay, so we started with 0, which is this one, and then we went 1, 2, 3 to get 3L, then 4, 5, 6 to get 6L, 7, 8, 9, but it's the usual, you leave off the last one. Okay, so that's so you could use step sizing. And the other trick to indexing or slicing is that you can use negative indices. So if I do L of -1, that's 9. So the number, start numbering them from right to left at 1, -1, -2, -3, -4, so on. And you can use the negative indices in the slicing. So if I do 3 colon -2, okay, let's see what we get. 3, 4, 5, 6, 7, didn't get the last 2, -1, -2. So we didn't, -2 is excluded, of course, because of the right hand, open on the right convention. And that would lead you to think you can do the same thing you can list things in a list without indexing them. You can say, here's L, so let's do 4 item in L. Oops. 4 item in L, colon, print item, and then end the for loop. So it just takes the first element, prints it, second element, prints it. Item goes from, runs over all the things in the list. So that's all pretty cool. And in order to get an idea of what's really going on, it probably takes some visualization. One thing we can do, which is kind of cool, is you can take assign to a sublist. So let's do L3 to 6, and that has 3 entries. So let's do L3 to 6 equals, I need 3 entries, 100, 200, 300. Okay, so it's better if you do print L. So replace those entries with 100, 200, 300. Right now, what counts is you have an ordered list over here, so it knows where to put them and which order these are in. Okay, well, let's go back to the old L. So let's say L is construct example 10, 20, let's do 10. Enter character L. And then, so that's got that. Then let's let L of 2 be S, which should be still floating around. And then we've got print L again. Okay, so that's where we were before. Okay, so a very useful site when figuring out this stuff is pythontutor.com. Not that. Here's pythontutor.com. So you can visualize your program as it executes. There's actually more than one possibility for the language. It doesn't have to be Python, but that's what we're doing now. So let's create a program here. Let's first set L equal to this stuff. So let's copy that, and then let's go back to here and do L equals, paste that in, and so there's L. And let's take a look at what happens if you execute that one-line program. Okay, so we haven't executed anything yet. So here's next, we'll do step 1 of 1. So it gives you a nice representation of what's happening in memory. This is the global frame where the global variables like L live, the script file. And this thing, we allocated some memory for it. We made that point to there. One entry is a reference to another list over there. So that's the structure we have for L. Okay, so one thing that happens there then is, suppose we make it equivalent to L and see what happens. So let's go back to editing this, and let's say list T equals L. So let's visualize execution. There's where we were, there's T. So we have T pointing the same place as L does. You remember I said that Python does not have variables, it has labels. So we first created all this stuff and slapped the label L on it, and then we slapped another label T on it, and they should be able to, they're the same thing. Changing T will change L, and changing L will change T. They refer to the same structure. So let's take a look at that. Suppose you do T of 5 equals 17, and then let's do print L. So let's see, start, and let's go 1. Okay, that's where we are. We create T. We did manipulated T, so we went to T of 5 equals 17. So here's T. T0, 1, 2, 3, 4, 5 gets equal to 17. But you can now see what happens when I print L. L is pointing exactly the same place. So here's where the printout is up here. It prints out exactly what you would expect with 17 in that slot. So you have to watch closely and see if you're doing this. If you're doing this, you should do it in, you have to visualize the structure so that you can see what happens. You don't want to be doing this at random. Okay, so in particular, that means that they say that Python parameters are passed by value, and that's true, but the value could be a list, a reference to a list, and that would mean you couldn't change what memory it was a reference to, but it doesn't prevent you from changing things in the list. So let's make a little function here. Let me get rid of these 2 lines. We don't need those anymore. So here's a function. Define set. I'll just call it set. L is a list. What should we call it? I don't want to call it capital L. I could, but LL is a list, and we'll set item N to value B. Okay, so now let's say block, and then let's just say LL of N equals B. And then let's just do return LL. Yeah, I don't even really need to do that. Let's not even return it. Okay, so there's the function. So let's run this code. So we produce the list with all that. It's L in the data frame, in the global frame. And then we do next, we get T, and now we're going to call L, so we get set, which is just a function, right? We hit this statement, it knows we're defining a function. We haven't defined the function yet because we haven't executed the function code. So we need to put in a call to that function. So let's say set list L item 6 to 31, and then let's do print L. So what happens? Okay, so let's begin. So we create L just by setting it equal to something we typed in. We hit the define set function. Well, we made T is the same thing as L. To define the set function, when you hit this statement, it knows it's a function and what the parameter list looks like. It doesn't know what the definition of the function is because we haven't executed the function yet. And then we're going to go into executing the function. So we go back there, and we passed L as the first parameter, so it got a reference to the same place L has. So here's another reference called little l doubled, which is to the same list. And then we do the next line, which is set LL of 6 over here equal to 31. So it should set that element equal to 31. And the return value of the function is none because I don't have any explicit statements. But you might think, well, it's useless. It didn't do anything, except, of course, that when you exit the function, all of the variables in the function, like LL, went away, but this stuff didn't go away, and we changed it. 31 right there. And then you print L, you get what you expect. Where is the 31? Right there. So by passing a reference to the list, you can change the list. And my construct example code is a similar thing. Let's take a look at that. So let's go back to the beginning. I want to start with a new program. I guess I can just erase this stuff. Okay, and then let's go back to my Python editor, and let's copy this definition. And then let's put it in into this block of code over here. Okay, so we define that function, and notice this one returns L. So it seemingly creates something out of thin air, namely L. So let's say construct example. Let's make it 6 elements, and distinguishing character is L. Well, it could be anything. I don't know what it is. Let's call it C for construct example. Okay, and then we return something, so let's collect the return thing. Let's call it A. So whatever is returned by this function will be stored, have the label A placed on it. Okay, visualize execution. Next, we hit the function definition, so it knows that's a function, but not what it does. And then we hit the construct example function, which steps us into the function with n equals 6 and ch equals c. So the first thing we do is construct an empty list. Local variable L is pointing at the empty list. And then we're going to go around this loop, and for each value of I, we're going to use the list method append. So we're going to turn I into a string and concatenate it with whatever that string ch was. And we're going to do that for each thing in the range. So in this case, we get 4C, 5C. That should be the last one. And now we go to return L. So we return L, and that's the return value of the function. But what happens when I put in A gets set to the same reference as the return value of the function. So I have indeed created a new list A by calling this function. So I can just, I didn't have to create it before I entered the function. Okay, so those are kind of weird effects of aliasing. And there's other ones, which is the difference between deep copy and a plain old copy. So let's let this be the same here, and then let's edit this code. Let's say we're going to make a copy of A as B. Well, one way to do it is to use A and use the list method copy, and see what we get. And then I'm sorry, I'm gonna change my example. I won't. Let's run this just to see what happens. Okay, so first we get the function. Then we call the function, we know what happens there, we went through it. And what we get is L, we get A, and now we do B equals A copy, and sure enough it makes B a copy of A, but not the same list. So no, it's no longer true that A and B point to the same thing. I can change A, it won't change B. I can change B, it won't change A. Another way to get a copy like that is, let's edit this code. Let's do C equals A, just with a colon. And let's see what happens when we do this. So next. We're building the list, of course. And then here's the return value, so we get A, B is a copy of A, and C is a copy of A. So A with the colon in it is really a copy of A. It really gives you a copy of A instead of A. And all of these are what's called a shallow copy. So what's a shallow copy as opposed to a copy? Well, let's get rid of this stuff. I guess what? Copy. Let's just go all the way back to the beginning. And let's use my list L for my Python examples down here with the this one, which has all of the has the sublist, and the sublist is what I want to talk about. So let's copy this, and then let's go back here, and let's let big L equals that stuff, and hit return. And now if you execute that one step, you get L as we arranged it before, which 2 entry is a reference to this sublist. Okay, now here's the trick. What happens if I do B, let's call it A. A is equal to copy, L.copy, and then I do A of 2 of 3 equals 17, and then I print L. Okay, the result might be surprising at first. So let's see what happens. So we start by setting capital L equal to the list we have. We make a copy of it. Oops, notice this part got copied and this part got copied. When we copied this part, we just took what was in number 2 and copied it to number 2 here, but it was a reference to another list. So both this slot and that slot are pointing to the same list. And so there's 2 ways to get at this list, and it will affect both of these. So if I do A23 equals 17, that changed this to 17. And if we do print L, name error, print is not defined. Print. Isn't that how you spell print? Didn't I do this quite a lot? Print, that's what I did wrong. A-L. Okay, so here we go. Close. Run, there's the list. There's the copy. And we're going to use A to access this element, which works right here. But then if we use L reference, we are getting the same list here. So we get, it did indeed change the element of the sublist when you list it as L. So this is something you have to sometimes do on purpose, but you better draw a picture so you know what's going on. Otherwise, you're going to confuse yourself. And so the copies we made here and here, that's my phone. Hang on. Okay, just ignore it. Sorry. So what we're going to do here is what happens if we, in this case we would say that A is a shallow copy of L, namely it copied the top level of L, but it didn't descend into any of these boxes to see what they had. So if you want really distinct copies, you want what's called the deep copy, and let's do that over here, and I'm going to quit there for the moment. So let's do import the module copy. That's one of the standard modules, and then let's say L B equals L dot deep copy. Visualize execution. So we know what's going to happen when we go here, here, there, changed it, print L. Okay, import copy. B equals a deep copy of L. No, list object has no attribute deep copy. You're okay. Yeah, I understand how deep copy is in the module copy. So let's do L equals deep copy dot deep copy, so we can find it. Let's make it L, and then over here I want to make it B. I'll be there. I'll be in there in a minute. So let's execute. Let's execute again. Okay. Print L. Import copy. B equals deep copy of L. So in this case, since it's a deep copy, it copied this, then it followed this pointer and copied what it has. So now if you fool around with B and L, this stuff will be independent of that. You've got two copies of this list, and they won't interfere with each other. So they say this is something you should draw a picture to make sure you're not confusing yourself, and whether you want to use copy or deep copy. Okay, I'm going to stop there. We'll talk a little bit. I'll do another video about lists. So let's sign off now.